Hi everyone, I hope you're all fine. So, yesterday we looked at a thermistor, we looked at what it is and its symbol as well. And we said a thermistor is a temperature dependent resistor. That means a resistor whose resistance depends on temperature. And we said when the temperature is low, the resistance of a thermistor is very high. But when the temperature is high, that means when it is hot, then the resistance of a thermistor is very low. So that is what we call a thermistor. And today we want to look at application of a thermistor. And in this case, we want to look at a circuit, a simple circuit in which a thermistor is used. So I want you to draw your attention to this simple thermistor that we have. The simple circuit that we have. As you can see, we have got an 8-volt cell, which is connected to a switch. And the switch is connected to the thermistor, this, and the bulb, which are of course in series. And then the circuit, you can see, is complete like that. Very simple circuit. Now you have got extensions at A, B, and C. That is AX, BT, and then CY. These extensions are to allow us connect voltmeters across XT, and which voltmeter will be used to measure the voltage across AB. We can also connect another voltmeter across TY, which will enable us to measure the voltage across BC. But of course, when the switch is complete, when the switch is on, current will then flow from the cell to A to B through the lamp, then to C through the thermistor, and back to the cell without flowing through AX or BT or CY because that circuit is not complete. Now, this bulb has got some specifications, as you can see. It's written 3 volts to 8 volts. So what does it mean? It means the operational voltage of this lamp is ranging from 3 volts to 8 volts. When you apply a voltage of 3 volts across this lamp, it will operate, but perhaps the lamp will be dim. If you increase the voltage to 4, to 5, to 6, to 7, to 8, the brightness of the lamp will be increasing, such that the maximum voltage that can operate this lamp is 8 volts. So that is the specification of this bulb. So to begin with, if we close our switch here, if we close the switch, current will begin flowing through this circuit. And because the bulb and the thermistor are in series, it means the 8 volts will be shared between the bulb and the thermistor. So let us see what happens if we connect the circuit when the temperature is very low. If the temperature is low, it means it is cold. And so we want to see the effect of the temperature, the effect of the coldness on the resistance of the thermistor. If you remember, we said at low temperatures, the resistance of a thermistor is very high. So if the resistance of the thermistor is very high, what does it mean? It means that the voltage across Ty will also be high. Let me take a figure here. That is voltage across Ty. You can see when it is cold, what is the voltage across Ty? Let me assume that the voltage across Ty is 7 volts. So if the voltage here is 7 volts across Ty, it means the voltage across XT should be equal to 1 volt. So that 1 volt plus 7 volts gives us 8 volts, as you can see, because these two are connected in series. So if we increase the temperature around the thermistor such that it becomes warmer, if it becomes warm, so when it becomes warm, it means the temperature of the thermistor is increasing. And when the temperature is increasing, then the resistance should go down. Resistance reduces. As the resistance reduces, then the voltage across the thermistor, that is voltage between T and Y, will reduce. So let us assume that from 7 volts, the voltage reduces to 5 volts. So if the voltage across Ty here, the voltage is 5 volts, what is then the voltage across Xt? As you must have seen, 8 volts minus the 5 volts here should give us 3 volts. So it means voltage across Xt is 3 volts. Remember what we said when we were describing the specification of this bulb. We said the minimum voltage required for it to give some light is 3 volts. And since the voltage here is 3, it means this bulb is going to begin giving light, much as it is dim light. Let's continue. If you increase the temperature around the thermistor further so that it becomes hot, it means because the temperature has increased, then the resistance of the thermistor is going to be so low. And when the resistance is low, you require a very small voltage to push current through this thermistor. So the voltage across Ty will be so low. Let us reduce it to 1 volt. If the voltage across the thermistor, that is across Ty from here to there, is 1 volt, it means the voltage across Xt is going to be 8 volts minus 1 volt. In that case, we are going to come out with 7 volts. So you can imagine if the voltage across this lamp is now 7 volts. What does it mean? It means it is going to give more light. So the bulb is going to be brighter than when it was 3 volts or even 4 volts or even 5 volts. So basically, this is a simple circuit that shows us how a thermistor can be used to vary the brightness of a lamp in a given circuit. So how is this arrangement used? This arrangement is used in so many electronic devices, including incubators, to regulate or warn against very low temperatures or very high temperatures. You imagine what is happening here. When it is very cold, the bulb is not giving any light. When it is hot, the bulb is giving light. So it means you're using this gadget as a signal to tell you, to warn you when the temperature is very high. For instance, if a house catches fire, you need to be warned if the temperature is too high. And again, in other circuit devices, electronic devices, we can replace this bulb with an electric bell. So instead of the bulb giving light, an electric bell can sound as a warning that the temperature is so high. Thank you.